Hi, everybody.
Hello.
My name is Michelle Kwon. You can call me Dr. Kwon. I'm your instructor. This class is face-to-face class, so you have to come here if you can. I'm saying that because as you can see on the course website, you can see Zoom live lecture. For every class, I will do Zoom live lecture together. So this is a face-to-face class, so you are supposed to come. But if you're very sick and whatever the reason can be, if you cannot come, then you can join Zoom live lecture wherever you are. There can be an occasion that you have a doctor's appointment or some other reason that prevent you to attend any type of live session, then you don't have to be worried about that because I will record all the lectures and post it here. After I finish the lecture, I will put the link with what topics I covered, and you can click it to watch it. What I have been saying is that the way you will attend this class may be somewhat flexible, even if I anticipate all of you appear every time. But what is not flexible is attending the lecture in a general sense, meaning you can come here and you can join Zoom live lecture, or you can watch it, and then you have to take attendance quiz. Every day when I give a lecture, I will give you 2 codes that will consist of 5 alphabetical characters. Let me click it. As you can see, I'm asking you to write down the code, first code and second code. You will just type the alphabetical characters here and here to get the attendance score. Deadline of each attendance quiz will be 2 days later. So today is Monday. The deadline will be Wednesday. So if you cannot watch the recorded video clip by tonight, then you can do it tomorrow or the day after tomorrow. So Monday's lectures deadline, attendance quiz deadline will be Wednesday, and Wednesday's lectures attendance quiz deadline will be Friday. Do you have any question about the regulation? Clear? But ideally, it is better to put the attendance quiz code right after the class. I tried to open the simple syllabus in my office, but I couldn't do it. So I'm not sure whether I'm remembering my office hour clearly or not. The Monday and Wednesday's office hour is from 11:20 to 1:15, and Tuesday, I believe it is 10 to 11:20. You can check it later by opening the simple syllabus. My office is on the 4th floor in the Mathematical Sciences building. I will do Zoom office hour together, but for Zoom office hour, you have to send an email so that you have an appointment through Zoom if you cannot come to my office. We have a textbook that is OpenStax textbook, so that is free online textbook. But most of students maybe never read the OpenStax textbook. Instead, they studied with lecture note. My lecture will be based on Newton-Alta homework problems mostly. Those will be equivalent version. And so if you study my lecture note, then you will have easier time in completing homework. If you go to the assignment, then you can see Newton-Alta homework like this and this and this. To purchase Newton-Alta, you would go to course materials and click opt-in. Then you will get deep discount, and the charge will go to your course, your student account. Usually the homework due date would be on Wednesday, but I suggest you to do homework by every Sunday. Other important thing I want to say is because of the Newton-Alta's some technical limit or issue, we removed the late homework submission. So I think that's the part of the reason the homework due date is shifted to Wednesday from Sunday. So you can just think homework deadline is every Sunday, but if we were sick, then you can spend some more time, but you have to complete it by Wednesday. But this week is the first week of the semester, so there will be no homework due this Wednesday. Homework will be 15% of the course grade. There will be weekly in-person quiz that will be closed book quizzes. So you have to come on quiz days. That will be every Wednesday. The quiz will be given in the last an hour. It is not an hour-long quiz, but what I'm saying is that if something happens and you have to come to the class late, then at least it should be an hour before the class ends, because that is the time something related to quiz will happen. I will now give the quiz at the beginning of the class. Default quiz range will be the materials covered previous week of the quiz week. But this is the first week, so I will not give you a quiz this Wednesday. The quiz will start from next week. Midterm exam will be 50% of the course grade. There will be 3 midterm exams. And I believe everybody know that exam will not be given during the class hour. You have to come to school at 8 o'clock. That is not on Wednesday, that is Thursday. And final exam will be 20% of the course grade. That will be given on December 5th, which is Saturday. Yeah,
Or the midterms, is that 8 AM or PM?
8 p.m. Yeah, at 9. And it'll end at 9:30 p.m. And if you are a SAS student, then you have to reserve your spot in the SAS testing center. You have to do it at least a week prior to the exam day. If you come to the regular exam place, then you cannot get an extension to finish the exam. About Yellowdig activity, you can go to Yellowdig by clicking Yellowdig here. Instead of having discussion board, I made a topic. It doesn't open. The topic that is ask your question. If you post any question, course general question, it can be mathematical question, then it'll be answered, but when you post it, I will not get a notification. So if you wanna have my answer quicker, then when you start, you will write and my name here. Then I will get a notification and my response will be quicker. But if that is about personal things, then you have to send an email to me. General introduction about Yellowdig is written here. The general topic in Yellowdig will be how to use AI. I encourage you to use AI to enhance your understanding and practice more with the type of problems you want to practice more. And also the help with prerequisite materials. So the required academic activity you have to finish by this Friday is tied to the prerequisite review of the prerequisite materials and the use of AI. I used this AI last semester. The majority of students said that AI was very helpful as long as you are not dependent on AI for everything. So what you have to know is that AI doesn't replace my lecture, and AI is not that good in explaining mathematical concept especially when that is related to visual things. And that is good to strengthen your understanding that is related to kind of formal knowledge and how to use something. And also generating prerequisite related problem or review. And you will be able to find how to use AI. But when I started to use AI, the obstruction was communicating with AI. If you don't communicate with AI effectively, then you cannot get effective help. So depending on how you communicate with AI, AI may give you better service or not that great service. That also means knowing the good way to ask, that means knowing the good prompt and format of the prompt will be very important. So what I try to teach you in this class, in this academic activity quiz is how to use prompt. How to ask AI so that you start to gain some insight about how AI behave. So preferred AI would be Copilot, ChatGPT, and Gemini. You can use either of them. So in this academic activity, I summarized all the essential formulas from Calculus 1 here and trigonometry. And this is from college algebra. You have to go through all the formulas and make sure that you know all of them. And those are your second nature, because if you cannot recall any of the formulas written here, you will have problems. So I also embedded the formula sheet here. You will download those formula sheets and just take a look at it every day so that you feel very familiar with all of them and you're not confused with any of the formulas. What I noticed in the previous semester was in the middle of the semester, students tended to be confused derivative formula with integration formula. So if you don't repeat it every day and everything is not your second nature, then you will have similar type of difficulties. Yellow activity topic will be suggested maybe approximately every 2 to 3 weeks. The participation will be voluntary. However, Yellow Dick score can influence your final course grade in a better way. I mean, it'll not participating in Yellow Dick discussion activity will not lower your course total. But by actively participating Yellow Dick activity, you may be able to get some extra credits, especially if your course total is very near the borderline. If you didn't participate Yellow Dick activity and your course total is slightly below the borderline, then the straightforward point will be given. Because in principle, I cannot just raise your score. I should have some score to be added from your extra efforts. So Yellow Dick activity score will be used in such a way, and that indeed at the end of the semester became pretty important. Do you have any question? In this first week, we will do the review of Calculus 1. I've heard the first week's homework is a little more than average week's homework. So you have to start it soon. The most important theorem you learned in Calculus 1 is fundamental theorem of calculus. Fundamental theorem of calculus tells us the integration is a reversing operation of differentiation. Let's suppose that the function f is continuous function on the closed interval a to b. And another function is defined by using the function f by integrating. The upper bound of the integration is a variable. Of course, a must be between a and b. So the situation is like this. We have y equals f of x. We consider the interval a to b. And x is any number between a and b. And g of x is defined as integration between a and b. So this one is g of x, area is g of x. Then what the fundamental theorem of calculus tells us is g of x is continuous and differentiable on the open interval a to b. And when we differentiate, it'll go back to the function we integrated. So integration is a reversing operation of differentiation. If the function f is greater than 0, that means if the entire graph is located above x-axis, then integration a to x f of t dt is area under the curve. You remember that how the integration was defined, that was defined by using rectangle and approximation. So when this rectangle becomes thinner and thinner, then when we add all the area of the rectangle, that'll get closer and closer to the actual area under the curve. So area under the curve. If we make the notation simple by using indefinite integral sign, so just to write integration f of x dx equals large f of x, then the fundamental theorem of calculus tells us f prime of x is f of x. Or we can just write integration f prime of x dx equals f of x. After you differentiate and if you integrate, then it'll become an original function. So that was the fundamental theorem of calculus. Basic integration formulas, you have to make a separate sheet and make sure that you remember all of them. Integration, number c times f of x dx can be written as the number c times integration f of x dx. And integration of f of x plus g of x dx is integration f of x dx plus integration g of x. When you calculate the function that has many terms, you can just integrate term by term. Important antiderivative formula. Are the derivative formulas you have to remember clearly. Here is a original function. This is antiderivative. We have a power function, x to the nth power. And n is not equal to 1. Then antiderivative is x to the n plus 1 over n plus 1. And 1 over x, if you differentiate, the integrate, then you got natural log, right? Natural log of absolute value of x. We have e to the x. If you integrate, then you will have e to the x again. If you integrate b to the x, then that'll be b to the x over natural log of b. If you integrate cosine of x, then that'll be sine of x. If you integrate sine of x, then it'll be minus cosine of x. If you integrate secant squared of x, then you have tangent of x. If you integrate secant and tangent, secant of x times tangent of x, then that is secant of x. If you do cosecant, cotangent, then that'll be minus cosecant of x. If you integrate 1 over 1 plus x squared, then that'll be tangent inverse of x. And if you integrate 1 over square root of 1 minus x squared, then that'll be sine inverse of x. As I said, all of them must be clearly remembered. It must be your second nature. Another important theorem was net change theorem. Integration a to b large f prime of x dx is large f of b minus large f of a. That implies large f of b is large f of a plus integration a to b f prime of x dx. Let's do some examples. The function value at 0 is given as -2. The question is, what is the value of the function value at 1 when the graph of f prime of x is given below? The graph is given as a linear function. This is not the function of f. This is derivative of the function. That means the original function is the parabola. But what we are interested in is getting a function value at 1, as you can see here. First thing you have to remember is f of 1 by net change theorem. F of 1 is f of 0 plus integration 0 to 1 f prime of x dx. F prime of 0, f of 0 is given in the problem here, that is -2, but f prime is given with a graph. Fortunately, that is a linear line, that passes through the origin. So we can easily find the equation of y equals f prime of x. To do that, we have to figure out slope, that is change in y, over change in x. By looking at the graph, you can see when you move 1 to the x direction, positive x direction, y drops by 2. So y change is -2 and x change is 1. So the slope is -2. As I said, that passes 0 and 0. So y equals f prime of x, which is -2 times x. Slope times x. We are going back to the net change theorem here to get f of 1. F of 1 is f of 0 plus integration 0 to 1 f prime, which is -2x dx. So that is f of 0 minus 2 times integration 0 to 1 x dx. Can you say easily about what is the integration of x? What is the integration? 0? Yeah, x squared divided by 2, right? So point is, this is x to the 1 power, right? And so when you apply the power formula here, you have x squared over 2. So f of 0 is given as -2 and -2 times x squared over 2 from 0 to 1. So that is -2 times -1 squared minus 0 squared. Any confusion? You can ask me if you're confused about something. So that'll be -3. Any question? A graph of f of x is given below the graph x. F of x looks like this. This is the graph of y equals f of x. You can draw the graph as you want, as long as you keep this point and this point. Problem is find the value of integration minus 1 to 5 f prime of x dx. What we know is by the net change theorem, it is f of 5 minus f of minus 1. So all we have to do is identify f of 5, that is 3, and f of minus 1, which is minus 5. So f of 5 is 3, minus f of minus 1 is minus 5, which is 8. Do you have any question? That was about fundamental theorem of calculus and net change theorem. The next important topic was substitution. I said derivative and integration are reversing operation. So if there is a rule in differentiation, there will be a corresponding rule in integration. Substitution corresponded to chain rule in derivative. Chain rule in derivative was applied to a composite function, f of g of x. Then that is f prime of g of x times g prime of x. Substitution rule in integral will be the counterpart of chain rule. Let's denote u equals g of x, and that is a differentiable function. On the interval I, and let's suppose that f is continuous on I. Then integration of f of g of x times g prime of x dx can be rewritten as integration f of u du. What's happening here is this g of u is written as g of x is written as u And so g prime of x becomes du. That was the substitution rule. In the subsequent example, what we want to do is we want to consider the application of substitution rule with power function. Evaluate the indefinite integral. What we know is integration of x to the n power dx is x to the n plus 1 over n plus 1 plus c. And if you differentiate x to the n power, then that'll be n times x to the n minus 1 power. Integration 18x squared times 6x cubed plus 8 to the 4th power dx by looking at the pattern, what you realize is it is pretty time consuming to expand out all the second function. But if you use substitution rule, then you can figure out the integration easier. What you have to notice from here is this is a product function. And when you differentiate this one, you will get exactly 18x squared. And you realize that this one can be regarded as a composite function of 6x cubed plus 8 and x to the 4th power. So inner function is 6x cubed plus 8. So we will put this one as u. So u equals 6x cubed plus 8. Then du will be 6 times 3 times x squared. This one will vanish. And dx. So du equals 18x squared dx. So what's happening here is we can rewrite it as this one is u to the 4th power. And 18x squared dx, that is du. Any question? Okay, so after you convert this like this, you will have easier time because that will be u to the 5th power over 5 plus c. But the original variable is x, not u. So you have to replace u by 6x cubed plus 8. So it becomes 6x cubed plus 8 to the 5th power over 5 plus c. Any question? The second problem is integration. 5x plus 1 to the 100 power dx. This time, this is raised to the 100 power. It is almost impossible to expand that out one by one. So we will apply the substitution rule. Inner function of this power function is 5x plus 1. So you will put that as u. Let's write it down. U is 5x plus 1, then du equals 5 dx. What is given is 5x plus 1 to the 100 power, and nothing else is there. But by differentiating the inner function, we got 5 dx. So you have to solve for dx. So that is 1 over 5 du. The given integral can be simplified to integration u to the 100th power times dx is 1 over 5 du. So that is 1 over 5 integration u to the 100th power du. So that is 1 over 5 times u to the 101 power over 101 plus c. And then that will be u was 5x plus 1 to the 101 power over 505 plus c. The next problem is a rational function. Integration 3x squared over x cubed plus 6 to the 7th power dx. We can regard this function as 1 over x cubed plus 6 to the 7th power times 3x squared, which is a product function. And what you notice here is if you differentiate this inner function of the power function, then you will get 3x squared dx. So this one is du. Let me write down. When we put u equals x cubed plus 6, du equals 3x squared dx. Given integration can be rewritten as integration 1 over u du. That means that is natural log of absolute value of u, not 1 over u du. There was 7th power, right? 7th power. So that is integration u to the minus 7th power du. So what does that mean? That means negative 6th power over minus 6 plus c. And that is minus 1 over 6 times 1 over u to the 6th power plus c. And so minus 1 over 6 times 1 over u is x cubed plus 6 to the 6th power plus c. Any question? The next problem is integration x square root of 3x squared plus 1 dx. Again, this is a product function. These two are multiplied together. And second function is a composite function, square root function with inner function 3x squared plus 1. So what we want to do is we want to put u as 3x squared plus 1. Then when we differentiate, we will have degree 1 function that is here. But we have to modify somehow because that is just x. And derivative of u is 6x. So u is 3x squared plus 1. And du equals 6x dx. All we can see here is x dx. So we divide by 6 on both sides. Then we have x dx equals 1 over 6 du. So we have integration square root of 3x squared plus 1 x times dx. So that equals integration square root of 3x squared plus 1 is u. And x dx is 1 over 6 du. So that is 1 over 6 times integration. Square root of u is u to the 1 over 2 power du. I am saying square root of x is x to the 1 over 2 power. If there is small decoration with n, then that is nth root of x. So x to 1 over nth power. So when we integrate, that'll be 1 over 6 times, I will just write down everything, 1/2 plus 1 over 1 over 2 plus 1 plus c. So it becomes 1 over 6 times u to the 3 over 2 over 3 over 2 plus c. And what we know is A over B can be written as A times 1 over B. The second one indicate reciprocal of denominator. So in this fraction, the denominator is 3 over 2. So that's 1 over 6 times 2 over 3. U to the 3 over 2 plus C. So that is 1 over 9 times U is 3x squared plus 1 to the 3 over 2 plus C. Any question? The next question may be a little bit elusive. We have integration x times x minus 6 to the 50th power dx. This is a multiplication product function. And we know that the inner function of the power function must be x minus 6. However, when you differentiate, you will get just dx, not x. What we want to do is we want to simplify the expression for the second factor so that instead of we have x minus 6 to the 50th power that we have to expand out, we want to simplify it to u to the 50th power that we can directly apply the integral formula. So it's important to convert x as a expression of u. If you observe a little bit more, after we write u equals x minus 6, you realize that if you solve for x, then you can get expression related to u, right? So we can write x equals u plus 6. And if you think about du, then that is dx. So that is integration. X minus 6 is u to the 50th power times x dx. And x is u plus 6 and dx is du. And then we will multiply integration u to the 51 power plus 6 times u to the 50th power du. Any question? So that is u to the 52 power over 52 plus 6 times u to the 51 over 51 plus c. So you can write it down as u is x minus 6 to the 52 power over 52 plus 6 over 51. You can simplify, but you don't have to. X minus 6 to the 51th power plus C. Any question? The next example is integration dx over 4 plus 9 x squared. Let's go back to the formula. I told you about the integral formula for 1 over 1 plus x squared. When we integrate, we will get tangent inverse of x. Problem here is the number, this part is 1 here, but we have 4 here. So what we want to do is we want to take out 4 from the denominator. So we have integration dx over 4 open parenthesis 1 plus we have 9x squared, but is there a problem?
No.
Okay. The second term in the denominator is 9x squared, but 4 is taken out, so we have to divide by 4 because after we expand it out, 4 must be cancel each other, so that we make 9x squared. And then we can rewrite it as 1 over 4 because just 4 is a number. Integration 1 over 1 plus. The way we want to write the second term will be 3 over 2x squared. Why? Because we have this formula that is 1 over 1 plus something squared. Now what's happening here is second term is a power function, but inner function is 3 over 2x. So we will put u equals 3 over 2x, then du equals 3 over 2 dx. So that is 1 over 4 integration 1 over 1 plus 3 over 2x squared. So that is u squared. And then we have dx, but with an integrand, there is no other number. So I will just solve for dx. Then dx is 2/3 du. I just multiply the reciprocal on both sides. So I would write here 2/3 du. So that is 1/4 times 2/3 times integration 1/1 plus u squared du. And that is 1/6 times tangent inverse of u plus c. And then that is 1/6 tangent inverse of what is u? That is 3/2x plus c. Do you have any question? You can ask me question. Before we do some trigonometric related substitution, trigonometric function related substitution, let me remind you of the trigonometric derivative formula. If you differentiate sine, then you will have cosine. And if you differentiate cosine, then you will have minus sine. If you differentiate the tangent, then you will have secant squared. If you differentiate cotangent, then that will produce minus cosecant squared of x. If you differentiate secant, then you will have secant x times tangent of x. And if you differentiate cosecant of x, then you will have minus cosecant of x times cotangent of x. Those are the formula you have to know clearly. Let's do examples related to trigonometric functions. We have integration sine of 3x over cosine squared of 3x dx. That is a fraction of trigonometric functions. When you compare the numerator and denominator has higher degree. The denominator is cosine squared. So we can regard cosine squared as a power function whose input is cosine function. Degree 2 power function with input u equals cosine of 3x. then du will be 3 times derivative of cosine is minus sine. So minus sine of 3x dx. So that's minus 3 sine of 3x dx. You can find sine 3x dx here. And so you have to solve for sine of 3x dx. And then that is minus 1/3 du. So for this one, it'll become integration. This numerator becomes minus 1/3 du. That is multiplied to this 1 over cosine squared of 3x, 1 over u squared. So I regarded this one as integration, 1 over cosine squared of 3x times sine of 3x dx. So this part is 1 over u squared, and this part turned out to be minus 1/3 du. And then that is integration u to the minus 2 power. And this is just a number. I would put that in front of integration. So that is minus 1/3 and du. Apply the formula, then minus 1/3 u to the minus 1 power over minus 1 plus c. So that is 1/3 times, so minus minus will be 1/3. U to the minus 1 power is 1 over u plus c. And then that is 1 over 3 times u was cosine of 3x plus c. Any question? The second one is integration minus x squared times sine of 5th degree, sine 5th degree, 5x cubed times cosine of 5x cubed dx. There are 3 functions which are multiplied. The highest degree factor is sine to the 5th power. So we will regard that as power function of degree 5 with the inner function sine of 5x cubed. So we will write u equals sine of 5x cubed, then du will be what? Cosine of 5x cubed times chain rule. The derivative of 5x cubed will be 15x squared dx. Let's rewrite this integration as minus integration sine to the 5th power 5x cubed times cosine of 5x cubed times x squared dx, so that we can arrange this closer to this expression. Then we find that this 15 is missing here. So we have to divide by 15 on both sides. Then that'll be 1 over 15 du equals cosine of 5x cubed times x squared dx. Let's rewrite it. Then that'll be minus integration sine to the 5th power is u to the 5th power. And cosine times cosine 5x cubed times x squared dx will be written as 1 over 15 du. This can be rewritten as minus 1 over 15 integration u to the 5th power du. That is minus 1 over 15 u to the 6th power over 6 plus c. That is minus 1 over 90. U is sine to the 6th power 5x cubed plus c. Any question? Did you understand? The next problem is integration 12x cubed times cosecant to the 5th power x to the 4th power times cotangent of x to the 4th power dx. Again, it has 3 functions multiplied together. And the highest degree term is cosecant to the 5th power. So if we put this one as u to the 5th power by substitution, then the problem is derivative of cosecant is minus cosecant times cotangent. What we can find is only cotangent here. But there is a way to overcome this difficulty. This one is cosecant to the 4th power times x to the 4th power times cosecant times x to the 4th power. Then we can regard this part as u, and when you differentiate cosecant, which is an inner function, you will get minus cosecant times cotangent, right? So we have to do some manipulation. So firstly, the inner function for this power function, power degree 4, is cosecant x to the 4th power. So we will put u equals cosecant of x to the 4th power. Then du will be minus cosecant of x to the 4th power times cotangent of x to the 4th power. This one is also composite function. So we have to differentiate the inner function and multiply. So that is 4x cubed dx. Let's rewrite the integration. Then that'll be 12 from here times integration cosecant to the fourth power x to the fourth power times cosecant of x to the fourth power times cotangent of x to the fourth power. We didn't write here, so times x cubed dx. So what we can see from here appears here, but 4 is extra. So we divide by 4 on both sides, then we will get 1/4 du. And there is no minus, so we multiply by a minus on both sides, then we have minus 1/4 du. And we have cosecant of x to the fourth power times cotangent of x to the fourth power times x cubed dx. So that is 12 times integration. So cosecant x to the fourth power is u. So this one can be rewritten as u to the fourth power. And for this part, cosecant of x to the fourth power, cotangent of x to the fourth power, and x cubed dx is minus 1/4 du, right? So that is 1/2 times minus 1/4 integration u to the fourth power du. So that's minus 3 u to the fifth power over 5 plus c. So that is minus 3/5. U is cosecant to the fifth power, x to the fourth power, plus c. When you take an exam, midterm exams, there will be free response questions. One of the common questions is how free response questions will be graded. Near the exam, I will give you review problems with web courses. That will help enormously for multiple choice problems. But what I found was when I compared the multiple choice problem and free response problems, students often struggle with free response question, and they don't know how to write the answers properly. So to strengthen that part, we will use AI. So one of the so what I want to suggest to you is tonight you will download Copilot, Gemini, and ChatGPT on your cell phone, because one of the assignment will use your cell phone. And what I will do will be I will give you free response type of question and will ask you to write down your answer as if you are writing an answer during the exam. And then you will take a picture of your actual writing and upload on the ChatGPT, Copilot, and so on. And then ask the AI about how many points can I get if I write this my answer in this way. And then what the AI will do for you will be it'll analyze your answer. Yeah.
You have like sort of rubrics to give the AI.
Yeah, AI will give you exact rubric, how that will be graded. And it doesn't have to be exactly the same as the rubric we will use, human-made rubric, but it'll give you approximate idea about how well written your answer is. So analyze your answer and explain what you are trying to do, but what is not enough and how to strengthen your answer and so on. That is very precise. So one of some of the web quiz will be just write your answer and then upload it on AI and then just make a screenshot and upload it and then write your reflection about how you improve yourself and then just do it again with a similar problem. And so the exact prompt will be given later. So what I want to ask you is download the ChatGPT, Copilot, and Gemini on your smartphone so that we can practice and strengthen with the free response question by using AI. Okay, so if you have any question, then you can ask me. Otherwise, we will see on Wednesday. Yeah.
Last semester in Calc 1, I ended up using Gemini was my choice because Newton also gave such a poor explanation.
Yeah. Yeah.